Today I'm going to show you how to deploy an application to the cloud. Though cloud deployment can be daunting depending on the technology and type of cloud product you choose, in many cases it's actually not that hard. I'll show you a few really simple ways to do it that are easy to get started with and don't require in-depth DevOps knowledge. I'm going to use Pulumi, which is an infrastructure-as-code platform to create a cloud application. They're also the sponsor of this video. I'll talk more about them later on. And I'll also talk about what infrastructure-as-code actually is and why I think it's going to change the way we do cloud deployment. But first, let's take a look at a code example. I'm going to use an example that I've shown in a previous video. This is a simple channel API. So what I'm using is Fast API to create a simple server. I'm using a channel class that represents a channel. I read channel information from a JSON file. So normally you would do this from a database, but I just kept things simple in this instance. And then we have a couple of endpoints that the API knows. So there is the root, which simply returns the server is running. And we have a channels endpoint that you can provide with a channel ID. And then it's going to find the channel information in the JSON data structure based on the ID and return that as a value. So there's also a Docker file that uses the latest version of Python, copies requirements, and copies the scripts to the folder and then starts the server using UVCore. There are different ways to deploy services to the cloud. It's mostly trying to find a balance between simplicity and flexibility. The simplest way to deploy something to the cloud is by directly letting your cloud provider run your code and attach that to a URL. If you're using Google Cloud, this is called Google Cloud Functions. In Azure, it's called Azure Functions, and if you're using AWS, it's called Lambda. It's really easy to set up, but you have very little control over how your code is run in terms of infrastructure. You don't use a Docker file in this case. You simply deploy your code and the cloud provider will set up a service that provides the application context. If you want more control over how your code is run, you can also opt for running a container built with Docker. Within Google Cloud, this is called Cloud Run. AWS has something similar called Fargate, which I don't have personal experience with. Microsoft Azure has container instances. This allows for more flexibility in how you want to run your code, but it's also a bit more complicated to set up since you need to create a Docker file, build the image, etc. If you need even more flexibility than this, you need full control over how to deal with services, containers, scaling, load balancing, and so on. You can create your own cloud environment or cluster run by a container orchestration system. The standard tool for this is Kubernetes, if that's how you pronounce it. Unless you know exactly what you're doing and you have a good reason for needing this, I wouldn't recommend this option. One of the two previous options is way simpler to set up. In most cases, it's all you need. So I won't cover Kubernetes in this video because I don't know how to pronounce it and it's a whole other ballgame, but I'll show you a few examples of using Cloud Functions and Cloud Run to easily deploy your code to the cloud. I'm going to use Google Cloud in these examples, but other cloud providers such as AWS or Azure have the same capability. Before we start creating cloud applications, we first need to set up Google Cloud. In order to set up Google Cloud, you first have to make sure you install the Google Cloud SDK, which is a command line interface tool. And then you need to log in so you can start interacting with your cloud environment. So in order to log in, I simply type GCloud auth login. This will open a browser, then you can enter your credentials and then you're logged into Google Cloud. The next thing you need to do is create a project that you're going to work in. So in this case, I created a project specifically for this video. So let's set that as the current project. Now, as I said, I'm going to use Pulumi to create the cloud resources. Pulumi is an open source infrastructure-as-code platform. What is that? If you have any experience creating and running cloud infrastructures, you probably know that it can become quite complicated and that there are many different kinds of settings to deal with. You may use YAML files to define resources, change settings directly in a command line interface, or do it in a web-based interface. Pulumi provides a way to define resources in code, using your favorite programming languages, IDEs, and package managers. So instead of dealing with YAML configurations or manual workflows, you write everything in code. And Pulumi takes care of provisioning resources to achieve the desired state of your infrastructure. It supports over 80 cloud providers and cloud native technologies like Kubernetes, which I still can't pronounce. But I definitely think you should give it a try. You can get started for free with Pulumi using this link, and you can also find it in the description of the video. Now, to get started with Pulumi, we need to make sure that it has the proper credentials to work with Google Cloud. So first we need to obtain the default application credentials that Pulumi needs to interact with the Google Cloud resources. Again, this opens a browser and then you need to give permission. So the first thing that I want to show you is a very simple, very basic project. This is more or less taken from the Pulumi documentation. I adapted just a few minor things. Here you can see an example of how you create cloud resources by simply writing Python code. So of course this depends on the Pulumi Google Cloud package. So we're using, in this simple project, we're using storage. And what's happening here is that we create a storage bucket. It's called my bucket. Well, you can change the name, of course, because this is simply code. So this allows you to store files in the cloud and access them externally if you want to. So I indicate that this is a website and that the default page is an HTML page. There's some other settings, like we don't need permission settings for every different file in the bucket. We're going to use the same permission for everything, which is normally what you want for a website. And that location is in the US. So this creates the bucket. This creates a storage bucket. Then what you can do in Pulumi is export certain names or values after you've created those resources. And then you can read what those values are in the console. And this is useful. For example, in this case, it's good for us that we know what the actual URL is of the bucket, so we can visit it and check that the website is actually working. So that's what we're doing here. And you can have multiple exports and you can basically export anything that you like. I'll show you a few more examples of this later on. Then we store a file in the bucket. So I create a bucket object that's called index.html, and that has a source, which is a file asset, index.html. And index.html, you can also see it here. It's very simple. It just contains an HTML with the body and a header, hello Pulumi. Then what we need to do in Google Cloud is indicate that everybody is able to view objects that are in storage. And this is of course very important, because if you want to have a website, this means that it needs to be accessible to the outside world. So everybody should be able to read that data. And that's what's happening here. So we have the bucket and we define a role, which is object viewer in Google Cloud. And we set that to all users, so everybody can view objects in the bucket. And finally, we export the bucket endpoint. So that's storage.googleapis.com/thebucketid/bucketobject.name. And this should probably be an SSL connection as well. So now our whole cloud architecture, which in this case is of course very basic, is now defined by this simple Python file. And now we can create the resources, and this is actually really simple. We simply type Pulumi up. The first time you do this, you need to log into Pulumi. So I'm hitting enter and then I'll log in using the browser. So now I've logged into Pulumi, and now the first step is creating a new stack. So in Pulumi, you can create different kinds of stacks for different types of deployments. For example, you could have a development stack, a production stack, etc., etc. So I'm going to create a new stack and I'm going to call that dev. So this is going to create a virtual environment using venv, and Pulumi sets all of this up and also installs any of the dependencies that you need. Now you don't have to create this whole project yourself from scratch. Pulumi has a couple of default projects that you can use to get started. So for example, if you want to have a Google Cloud project that uses Python, you simply type Pulumi new Google Cloud Project Python, and then it creates a new project for you. So I already did that here. In my case, this is called basic project. And next to the main file that you see here that I just talked about, and we have the index.html file, we also have a YAML file that contains the information about this particular project. So there's a virtual environment, and the project also has a description that you can edit if you want to. There's one more thing you need to do before you can actually create cloud resources using Pulumi, and that's that you need to indicate to Pulumi what the project is that you're going to use. And there's a simple way to do it. If you have the stack that you just created, then you can define a YAML file and put the configuration in there. So in this case, we're setting the Google Cloud project to ArjanCodes Pulumi. And this is going to make sure that when Pulumi updates the resource, it knows in which project the resources need to be created. So now that Pulumi has created the stack, we can perform the actual update, which will create the cloud resources. So I can pick here whether I want to perform the update, yes or no. So I'm picking yes. So now Pulumi has created all of the resources that I've defined in my Python code. And you see that there is now a couple of outputs. So these refer to the exports that are defined here. So there's the bucket endpoint. And if we go up a bit, there's also the bucket name. So for example, this is now the endpoint of my bucket. When I open my browser window to go to this particular URL, then you see that we are served the HTML file that we just uploaded. Updating the cloud resource is now actually also really simple. For example, let's say I modify this HTML file and turn this into hello ArjanCodes. So now I go back to my command line interface. I simply write Pulumi up, and it has detected that the index.html file has changed. So we're going to perform the update. Now when we open the page again, we see that the updated text is there. If you don't need the project anymore and you want to make sure you're not using cloud resources when it's not absolutely necessary, it's also really easy to destroy this again. In this case, you simply write Pulumi destroy. And this is going to delete all of the resources that we just created. This still keeps the stack defined in Pulumi. If you also want to remove the stack, then we can simply type this. And now our stack has also been completely removed. So both creating resources and destroying resources is actually really simple in this way. I want to show you a few more advanced things you can do with Pulumi. So this was a very basic project. I have another project here which uses a cloud function. So what I did is I rewrote my channels API so that you can use it as a cloud function in Google Cloud. That's actually pretty simple. Google Cloud functions rely on Flask if you're using Python. So what I did here is define a function that serves channels, similar to the example that I showed in the beginning of this video. Now we need to do a bit of a hack in order to support paths, because normally a Google Cloud function is simply a URL. So this is how I did it. I created an internal Flask app that I'm using for the routing within my cloud function. And then I define the route here. And then I have the actual cloud function, which I'm calling that hello name here. I should have probably called that something that's different from the default thing. But there I'm dispatching the request to this particular route. And then you can add multiple routes here if you want to. I'll put this code on GitHub so you can also take a look at how it's been set up. Other than that, I have a YAML file again that defines a cloud function. And I have a Pulumi file that creates the various resources that we need. So I'm using a constant here called path to source code. We also need to store the source code in a bucket so the cloud function can actually access the code. So that's what this is doing. Then what I'm doing is taking all of the assets that the cloud function needs, which is the source code. You need to zip it up into an archive. And that's what this does. And then we create a cloud storage object where we store this source archive that we created before. And then finally, we can actually create the cloud function. So we give it an entry name, region, the runtime. In this case, I'm choosing Python 3.10 and referring to which bucket contains the source that the cloud function should use. So it's not completely trivial to do this, but once you've set it up once, it's very easy to adapt this to what you need. So again, the source code for this is all in GitHub. So you can use that as a starting point for your own cloud system. And then finally, we need to indicate that this is a public-facing cloud function so that everybody can invoke it by going to the URL, similar to what we had before. And then there's a couple of exports. So I'm exporting the DNS name and I'm also exporting the function URL. So if we want to deploy this, it's again very simple. We write Pulumi up. And first we're going to create a new stack. Let's call that dev again. And now we can perform the actual update. Now the update is complete and we get a URL to the actual cloud function. So now go to that URL. Normally nothing is found because we're routing to the channels path. So I need to write, let's say, channels ArjanCodes behind it, and then it's going to serve up the data. So now I can build out this cloud function and add other API endpoints. And as you can see, it's actually really simple to do this. For example, I could add another route called test server. And this is a GET request, like so. And this is simply going to return a response. The server is running like so. And let's update the resource. So Pulumi has detected that the cloud function needs to be updated, but that the other resources are still valid. So let's update this. So now the update is complete. We can go to the function URL. And now if I write test server, we're going to get back that the server is running. And this shows that we now have the updated resource available. And then of course you can take this URL in Google Cloud and replace it by your own custom domain if you want to. The final type of cloud setup I want to show you is a Cloud Run project. So as you maybe recall, Cloud Run allows you to define a Docker file and then run that Docker file in the cloud with Google taking care of automatic scaling. And as I mentioned before, the other cloud providers also have a similar kind of product that you can use for that. So here in my Cloud Run file, I'm actually building a Docker file, uploading it to a Docker registry. So here I create a container registry on Google Cloud. That's what these lines of code do. Let me make this a bit wider. Then the next step is building and publishing the container image. So I'm building a Docker image here based on the Docker file that I provided here. So this is the example from one of my previous videos. I'll put a link to the video at the top if you haven't watched that yet. But this is the Docker file, and we have the main file which uses fast API. There is also requirements.txt file that contains all the packages that are needed. And in the main file we built and published this Docker image. Then the next step is creating the actual Cloud Run service. So that's how this is done. And of course here we specify which container we're going to use, which is this image that we created here before. Also here we have to say that the URL at which the service is available is going to be readable to everybody. So it's a public facing service. So that's what these lines of code do. And then finally, I'm exporting a few things like the base image name and the actual URL of the service. And let's update the service just like we did before. So we create the stack and now we're going to perform the update. So again, we have a couple of outputs here like the service URL. And when I open this, you see that we get the message the server is running, which is the root GET request. But I can also get channel information here again. So this works in exactly the same way as the cloud function that I showed before, except that we now have more control. We can define our own execution environment in the Docker file and use a specific version of Python, install extra requirements, other tools, whatever we want to do. So again, the full code for this example is in GitHub. What's nice about infrastructure as code is that you can actually use the full power of Python when defining and deploying your cloud resources. So here I didn't really do that very much. I mean, if you look at the main file, I'm simply using the Pulumi libraries packages to define the various types of resources that you see here. But here I created another version of this exact same Cloud Run resource. But there I used some of Python's features like defining a couple of constants and putting things into functions. So here I have a function that creates the registry. I have a function that builds an image that creates the Cloud Run service. You can apply software design principles to split up things and make your cloud resources easier to manage, because of course these things you can reuse in different kinds of environments. So you can really set up a pretty complex cloud deployment environment using code, which is just really cool in my opinion. There's also a way in Pulumi to define custom resources in a more object-oriented way, what they call a component resource. So what you can do in Python, for example, is create a class, myComponent, and that is a subclass of Pulumi.component resource. And then you can create any resources that belong to this component inside this class. One thing you may have noticed in this version of the Cloud Run function is that some of these functions return so-called Pulumi.output, and some of them expect a Pulumi.input. So what is this? Well, inputs and outputs are basically generic types that you can pass a subtype. In this case, these are strings. An input is a type that permits either a raw value of a given type, such as string in this particular example, or some kind of asynchronously computed value, like a promise or a task. Or it can be an output from another resource's property. So that's actually what you're seeing here, that the registry outputs a string, and then we're actually using that in other places again. Any properties related to resources that you create are called output properties. Doing it in this way is actually needed because when you create a resource, you generally have to wait until the cloud provider has created that resource. So it's not immediately available. That means it behaves as a promise. So these things represent various resource values, like in this case, registries, images, cloud services, and so on and so on. But next to representing the actual resource values, outputs are also used by Pulumi to keep track of which resources are being created and when they need to be updated. Final note, if you need to install new packages while you're deploying things already to the cloud, make sure you also update the requirements in the virtual environment that Pulumi is using. Otherwise, it won't be able to recognize that. As you see, it actually creates a virtual environment here that contains all the libraries and packages that you're going to need. So if you want to make sure that these things are installed, you need to do venv bin pip and then do install requirements.txt, and then any requirements that you add to the file are also going to be added to the virtual environment. This is actually a problem I ran into while I was preparing the video, so I thought I'd mention it to you so you can avoid that. I think infrastructure as code is very interesting technology. In my opinion, this is the direction that DevOps should go in. So where will this technology take us? I think a great next step would be to have a generic layer that allows us to define cloud resources independent of whether they're running on AWS, Google Cloud, Azure, or any other type of cloud provider. I totally understand that this isn't there yet though. It's still very new technology and cloud providers are still actually figuring out what cloud infrastructure actually is. I mean, it's not that long ago that Kubernetes wasn't the main technology used for container orchestration. That only started happening in around 2018. With Kubernetes and infrastructure as code, defining a generic layer definitely seems feasible. If we define what the cloud infrastructure is using Python code, how far can we take it? I mean, could we have a machine learning algorithm that looks at infrastructure usage data from the past, predicts how many resources you're going to need, and then writes a Python application that automatically creates or destroys these resources to minimize costs? Is that possible? Would it make sense? I'm curious to hear your thoughts about this. Let me know in the comments. Anyway, I hope you enjoyed this deeper dive into cloud deployment. Thanks again to Pulumi for sponsoring this video. Don't forget to check them out via the link in the description. Now, if you want to learn the best practices for DevOps and how to best set up your cloud service, check out this video. Thanks for watching, take care, and see you next week.